All right, we are on to 8.3, which is circles and circular figures. All right, so first of all, we have a circle. Remember, the two formulas we're using here is area of a circle, pi r squared, and circumference, which is 2 pi r. Usually for me to remember the difference is remember area is in units squared, and that's the r squared part, and for the area formula, circumference. Besides 2 pi r, you can also do pi times d, right, times the diameter, 2 times the radius of the diameter. So if you want to do pi times d, that's also another option for you, all right? So exact area. When we see exact area, that's telling us they want it in terms of pi. We're going to leave pi in our answer. And when we do that, we're going to treat it like a variable. So if it's like 7 pi, it's just like doing 7x. So if you have 7 pi plus 9 pi, you can add it together and get 16 pi. So you're just treating it like a variable when you're doing this, okay? So with a radius of 7, and we're doing circumference, so c equals 2 pi r, okay? And then 2 pi times 7, and then we just do 7 times 2, 14. We'll leave it like a variable and just 14 pi. Exact circumference, if its area is 144 pi. So here's a step up. Remember, circumference, we need 2 pi r, so we need the radius first. They're giving us the area, okay, which is in terms of pi. So we know area is supposed to equal pi r squared. And here we have 144 pi is equal to pi r squared. Remember, we talked about in the past. Don't square root until you have the squared term, r squared by itself. So my first step is divide out by pi. Those will cancel out. I get 144 equals r squared. And now I can take the square root and get 12 is my radius. And then I got to go back over here to the circumference formula and plug that in. So 2 pi times 12, and that's equal to 24 pi. All right. Now, round to the nearest hundredth, that means I'm going to use the pi button on the calculator here, okay? So it says a circle has a circumference of 21.98 meters. So once again, my formula, 2 pi r, I plug in 21.98. And for the circumference, and here I'm going to divide by 2 pi, and then I'll have my answer. And I just want to round accordingly, so it's going to be a repeating decimal here. All right, so we just do the old 21.98. And here I have two things, so I'm going to use parentheses, so just divided by parentheses, and then 2 pi. All right. And there's my answer there. 30.498. Here's hundredths, so 2 decimal places would be the 9. This bumps up to 3.5. And we're going to leave it as 0 because we want hundredths there, okay? All right. So the next three-dimensional shape, polyhedron, if you will, is going to be a cylinder. So a cylinder has two parallel congruent bases that are circles, okay? And the height is the altitude that connects the bases. So remember, if it's a right cylinder, the height is actually the side length. If it's oblique, we're going to need to get that side length and just drop that altitude down. So it's perpendicular to the way the base is. So it has two bases. The shape of the base is a circle. Okay? So there's two formulas we need to know here, the lateral area and the surface area. Now, if you have, okay, get a small piece of paper here maybe. All right. If we're looking at a cylinder, okay? All right. So there's my cylinder, okay? You guys can see it. And we cut it open, right? What do we get? We get a rectangle, okay? And so what are the parts of the rectangle? Because this is where we talk about surface area and lateral area here, okay? So if we're doing the cylinder, right, we want to do this lateral area. Because remember, lateral area means there's no bases. There's open ends on the bases here, okay? So we cut it open, we're going to get this side of it right here, which was the height, right? And then this side, which was the round part, that's the circumference. So really, when you're doing the lateral area, it's the circumference, 2 pi r, times the height, So the circumference times the height. 2 pi r h. Okay, so that's the formula we're going to be using for the most part. You can also use pi dh. Okay, remember surface area is the lateral area plus 2b. So you end up getting 2 pi r h plus 2 pi r squared. Okay, so here we take our cylinder, cut it, and this is what we get, the two circles, and then this part's the height, and this part right here is the circumference. Okay, and the area of the base, remember, is just pi r squared, and we just do that accordingly. All right. So find the lateral and surface area of the following shapes. I'll do the first one. I'll do the second one for you guys. So lateral area is just 2 pi r h, circumference times height. So it's 2 pi r, which is in this case 3. So we'll do 3, and then the height, which is 5. So lateral area. Now, it doesn't say what to round to. So in general, there's no rounding. Just leave it in terms of pi. That's your exact answer. So treat it like a variable. We have a pi in our answer. And then just multiply 2 times 3 times 5. So 2 times 3 is 6. 6 times 5 is 30. And then inches squared. Okay? I'll leave this one for you guys on your own. We're going to do the surface area next. Remember, that's the lateral area plus 2 times the area of the base. So if we treat it just like a normal problem, and then we have the answer to the lateral area here, okay? So when I plug in, it's 2 pi times 3 times 5, which is our 30 pi, plus 2 pi times, in this case, 3 squared. So, not a surface area, right? We know this is 30 pi. This is 9, and 2 is 18, so 18 pi. And just like a variable, we treat these just like a variable, so we just do 30 plus 18, and this becomes 48 pi, and then inches squared, right? Okay, next shape is cone. Now, cones are different. There's only one base here, so just like a pyramid, if you remember how we had a prism was p times h, right? Pyramid base times the height. And then we did half of that, and we used the slant height. So that's going to come up again as a slant height. So the bases, once again, there's one, and it's a circle, okay? And the lateral and surface area formulas, once again, are coming from the fact that if I take a cone and I cut it and open it up, I get this sort of triangular-looking shape here, okay? Kind of like a slice of the pizza here, okay? And so the formula I get is 1/2 times the circumference times the slant height. And what happens is the half and the 2 cancel, and I'm left with this formula pi RL. Okay? So pi RL is the lateral area formula for a cone. And then the surface area formula is just pi RL plus the area of the base, which is pi r squared. And that's it. All right? So that's all we end up getting for this in terms of surface area and the lateral area. So find the lateral area and surface area of the cones below. So we'll do this first one. I'll leave this one for you guys. So lateral area is just pi r l times the slant height. Okay, and then all we're going to do here is pi r once again is 15, and l is 25, and we just multiply. So 25 times 15 is 375, so this is 375 pi. And then the surface area is the lateral area plus pi r squared. So if you were doing this normally, I would say just put 375 right here. We already know what it is. We don't have to mess around with it. And this is just pi times 15 squared. So it's 375 pi plus 225 pi. And then we just add them up. So that's a 0. Carry the 1, 9, 10, boom, and I think that's 600 pi. And then we got centimeters squared. Again, still area. This question is a little bit harder, and as well as this one, because you don't have the slant height, which is what you would need. So if you're doing this question, we know this is 80, so this side right here is 40. We have this is 45. So here, once again, you have a right triangle, and we're just doing the Pythagorean theorem. So 40 squared plus 45 squared is equal to c squared. And then we just do the math. we get 3,625. Take the square root. Okay, so square root 3,625. That's equal to C, or equal to the slant height. Okay, and then we would just use that. So when we do pi r L, we literally just do pi times 40 squared times this radical. That's the exact answer. Okay, so just keep that in mind. So we know 40 squared is going to be 1,600. So this is 1,600 pi times the radical 3,625. Then there's no rounding involved. So this is my exact answer. And then I just add on the area of the base, so plus 40 pi, or 40 squared pi. And then you won't be able to add that because there's no radical there, but that would be your surface area. So, okay. We got two weird looking shapes here, and we're trying to find the surface area of each. So just keep in mind two things. Number one, surface area is the area of the outside surfaces, right? So it's going to be the part of the cone here, right? This circular part is not actually seen, okay? So this is inside the shape, so I'm not actually seeing this. However, there is a bottom circle down here that would be seen, okay? So all we want is the sides of the cone without the base, and remember that's the lateral area of the cone. And then I want this size of this figure, so that's the lateral area of the cylinder. And then I just want the bottom. I want a base. So when I'm doing this shape, I'm going to keep in mind that part of it I won't be able to see, the other part I can. So just think about, like, what's this called? This part's the lateral area. That's the lateral area. That's the base. And then you're just going to put them together. Okay? I'll leave you guys to do these two as well. All right, next one is a sphere. So a sphere, once again, is a set of all points equidistant from a center point around a shape. All right? And so what happens is when you can cut, kind of like, think about an orange, right? You cut an orange through the middle, you're going to left with the circular part here, and then another round part where the two circles are, okay? And when you cut through, if you cut right through the center of the orange, you get what's called a great circle, okay? So the great circle is the largest circle you can make, all right, around the outside of a sphere. This is what we use to figure out the surface area, though. So we're going to use, when we do the formula, which we're going to take a look at in a minute, is 4 pi r squared. We're always using the radius of that great circle, okay? So when you cut a sphere in half, just like the globe, you get two hemispheres. So a hemisphere is half of the sphere, okay? And the circumference of the circle is also the circumference of the sphere. All right, so you can find the surface area if you know the radius, and all we need there is then the formula, which is just 4 pi r squared. There's no lateral area to a sphere, because there's no base to it, so it just has a surface area, and we'll talk about volume a little later, okay? So what's the surface area of a sphere with a diameter of 14? That means the radius here is 7, so we just do surface area equals 4 pi r squared. We get 4 pi times 7 squared. This one says round, so we are going to use the pi button on the calculator here, right? So we do 4, and then eventually it should be times 49 here. So 4 times 7 squared. And this time we're going to do times pi. Remember, yours is down here in the other calculator, so just calculate that. And then we end up with 615, right? And it says nearest square inch. The next number is the 7, so we're going to round up. So this is 616 inches squared. Okay? It does say in terms of pi, and we're going to do both. So if that's the rounded, so normally actually what I would do is get pi first. So this is really 49 times 4. Should have read the directions before I started. Which is 196 pi. And then when you do the 196 pi in the calculator, you see we get that answer right back. So now we know the surface area is equal to 616 inches squared. Okay? All right, number 8, we'll take a look at it because it's a little different. The Earth's equator is about 2,902 miles long. If you remember, the equator goes around the outside of the Earth. So technically, when we're talking about this, we're talking about the circumference. What's the approximate surface area of the Earth? Rounding it to the nearest 1,000 square miles. So I'm going to start with circumference is equal to 2 pi r, and then we're going to plug that number in. So 24,000 902 is equal to 2 pi r. Here we want to get r by itself, so we'll divide by 2 pi. Remember, you can either use the fraction of r or make sure you the parentheses here. So 24,902 divided by parentheses 2 pi. Close it out, hit enter. And I get this lovely number right there. So I don't want to round yet, okay? So what we could do is leave it as a fraction instead of having to write this all out. So if I just divide this by 2, I get 1,000. How about 12,451 divided by pi? That's technically the radius. Or you're going to have to write out this long number. Remember, we don't want to round here, because rounding now is going to give us an incorrect answer. It could possibly give us an incorrect answer later. It could be off by tenths or hundredths, which could be, when we round it here, right? Rounding the nearest, it could throw off our answer. So the next thing we want to do is figure out the surface area, and that's 4 pi r squared. So all we're going to do is 4 times pi, that's 1,200, so 12,451 over pi, and then square it. If you want to use that decimal, that's totally fine. Okay, no big deal here. In this case, we're just going to do 4 pi parentheses 1251 over pi. Okay, and then we square that guy, hit enter, and there's our answer. Now this says to the nearest 1,000 miles, not thousandths. So when it says 1,000, that's actually talking about the 1,000 number. So this is the thousands place right here, right? Tens, ones, tens, hundreds, thousands. So if I'm rounding to this, it's closest to 7,000 because it's 7,017. So this is, we're going there, right? 1, 2, 3, 1, 2, 3. So here's 197,387,000. That would be the nearest 1,000, okay? And that's square miles. So mi squared. All right, and then your homework here is on the last page. So we'll do a little extra credit today if you're in Mr. Zazowski's class. And if you want to finish the worksheet for extra credit, go for it. Homework tomorrow. This worksheet right here, okay, is due. All right, guys. Good luck. Let me know if you need anything.